This is Fort Stewart, Georgia. What you're looking at is enough armored firepower to level a small country. 87 M1 Abrams, 152 Bradleys, and over 4,000 vehicles sitting in rows on a rail yard. In 72 hours, every single one of them needs to be gone. Because somewhere approximately 7,000 miles away, an infantry brigade is patrolling without armor, and the clock started ticking 3 days ago. Getting these tanks to that fight will require an army to hand $1 billion in combat equipment to people it doesn't control, on an infrastructure it doesn't own, through a pipeline so fragile that a commuter train in Georgia can delay reinforcements in the Middle East. It starts with this train, but before a single vehicle moves an inch, every one of those 4,000 pieces has already been assigned a position in the load order. Not by size, not by type, but the order it needs to come off the ship on the other side of the world. The first vehicle that rolls off in Kuwait was the last vehicle loaded in Georgia. The entire staging grid works backward from a battlefield 7,000 miles away, planned by logistics officers working from satellite imagery and deployment orders that change 3 times before the first tank hits a flat car. Every mistake in the sequence means a scramble to reorganize on the receiving end, where the aforementioned infantry brigade is indeed operating without armor. So every vehicle sits in its assigned row, washed and sequenced, waiting for its turn on the ramp. And yes, washed. Soldiers scrubbing treads, blasting undercarriages with pressure hoses, picking mud clots out of the road wheels by hand. The U.S. Department of Agriculture requires every military vehicle crossing state lines to be free of invasive soil species. The rule applies equally to a cattle trailer in Oklahoma and a nearly 70-ton main battle tank in Georgia. Red Georgia clay on a flat car in Texas is a federal violation. Troops overseas waiting for these tanks don't care about invasive soil species. The USDA does, so the pipeline stops for a pressure washer. But before an Abrams goes anywhere near a flat car, the crew locks the turret forward and clamps the 120mm gun barrel into a travel lock, a steel brace that holds it rigid for the trip. The turret alone weighs about 22 tons. If it rotates freely on a moving train, that weight shift on a curve could roll the tank right off the car. The flat cars at the railhead are DoD ex-military specification heavy haulers, 68 feet long, bare steel deck, no wood planking, with recessed tie-down rings welded into the frame and a depressed center section that sits lower than the ends to keep the tank's center of gravity below the rail clearance envelope. Each car is rated for 140 tons, 1 tank per car. When that Abrams drives up the portable steel bridging ramp and onto the deck, the driver is lying in a semi-reclined position in the front hull, steering with a motorcycle-style T-bar. Twist the right grip to accelerate, turn the bar to steer. The AGT 1500 gas turbine behind him whines like a jet engine at idle. He's looking through 3 periscopes that give him a 120-degree view of the world ahead. Narrow, segmented, and nowhere close to showing the edges of the flat car. The treads overhang the sides of the car, and the clearance is measured in inches he'll never see from the inside hull. A ground guide stands at each corner with hand signals, his only reference point. 1 wrong input on the T-bar, and 70 tons slides off the side of a flat car from 5 feet up. The ramp flexes under the weight. The whole car tilts. Nobody breathes until the tank is centered and the driver cuts the engine. Multiply that by 87, and the tanks are barely the beginning. Those portable bridging ramps get repositioned after every vehicle. Tracked vehicles need a wider span than wheeled ones, and the ground clearance is different. The loading crew leapfrogs the ramps forward down the line, disassembling and re-leveling steel spans that flex under 70 tons while the next tank idles 20 feet behind them. Every vehicle gets chained down at exact hard points with links thick enough to anchor a fishing trawler. Torque to precise specifications, too loose and it shifts in transit. Too tight and the chains snap under load. The soldiers doing this carry torque wrenches calibrated to the foot-pound, because on a moving train, close enough is the difference between a secured load and a 70-ton projectile. The locomotive pulling all of this isn't one engine. It's a distributed power configuration, multiple locomotives at the front, middle, and rear of the train, all controlled by the lead engineer through a radio link. A train this heavy can't be pulled from one end without buckling the middle cars on curves or dragging the rear off the rails on a downhill grade. The engineers manage throttle and braking across all units simultaneously, balancing forces across a mile-long chain of steel. When the lead locomotive finally pulls forward, 400 flat cars lurch against their couplings simultaneously. 4,000 vehicles testing their restraints all at once. You can hear the steel groan from a quarter mile away. The time to load everything? 72 hours. And if a tank throws a track while driving onto a flat car, and it happens more often than anyone likes to admit, the entire loading sequence behind it halts. Recovery vehicle in, tank off, replace the track, restart. 2 hours minimum. And those 2 hours don't stay at Fort Stewart. They follow the convoy onto the railroad, ride with it through 5 states, and arrive in Beaumont as 2 fewer hours of inspection time for vehicles that haven't been checked yet. Every delay at the front end of this pipeline arrives at the back end with interest. That train is now about to spend 5 days crossing half the country on tracks the Army doesn't own, and the pipeline just handed its first dependency to someone else. Once that convoy leaves the railhead, the U.S. Army loses something it doesn't give up easily: control. Every mile of track between Fort Stewart and the Gulf Coast belongs to private freight companies. CSX, Norfolk Southern, BNSF. The Army doesn't own a single mile of railroad outside its bases. It rents space on a commercial network. The same rails that carry Amazon packages, grain shipments, and Amtrak passengers. Under federal law, passenger trains take priority over everything. Federal statute, the Passenger Rail Investment and Improvement Act, means an Amtrak commuter train from Jacksonville to Savannah gets right-of-way over a military convoy carrying $1 billion in armored vehicles. So $1 billion in armor sits on a siding and waits for the 315 to Jacksonville. Every hour on that siding is an hour U.S. soldiers are patrolling without armor. And right now, their tanks are parked behind a commuter train in southern Georgia. Military transportation officers ride escort, but not in uniform. They travel in civilian clothes, riding in the locomotive cab or a crew car attached to the consist, monitoring every mile, every switch point, every bridge crossing with satellite phones and direct lines to dispatch centers at both ends of the route. Unable to speed the convoy up, unable to reroute without approval from a freight dispatcher in a commercial office building. Route planners at the Surface Deployment and Distribution Command, SDDC, the logistics command most people have never heard of, didn't just map the route. They pulled bridge engineering data from the Federal Railroad Administration, cross-referenced it with the specific axle loads of a DODX carrying a loaded Abrams, and flagged every structure that fell below the weight threshold. For marginal bridges, they sent engineers to physically inspect before clearing the convoy. Every bridge on this route was stress-tested on paper, and sometimes in person, months before the first flat car rolled. One bridge that can't handle the load reroutes the entire convoy, sometimes adding a full day. An M1 Abrams on the ground spreads its weight across those wide tracks so gently, 15 pounds per square inch, that it treats pavement better than a Honda Civic. But a bridge doesn't care about ground pressure. A bridge cares about total weight. A single Abrams on a DODX flat car is 140 tons, the tank plus the car. That weight makes rail the only option. $66,000 per mile to move an armored brigade combat team under its own power. Per mile. The Abrams drinks between 1.5 to 3 gallons per mile depending on terrain. Drive this brigade from Georgia to the Gulf and you'd burn through tens of millions of dollars in fuel before a single tank reached saltwater. The convoy crawls 30, maybe 35 miles an hour through the flatlands of Alabama and Mississippi, slower through rail yards where switch points route the cars onto different tracks. Anyone standing at a railroad crossing in rural Louisiana at 2 in the morning can watch the entire armored brigade roll past at jogging speed, one flat car at a time, for 20 minutes straight. 5 days after leaving Fort Stewart, the train pulls into a rail yard on the Gulf Coast where the air smells like refinery exhaust and the heat comes off the concrete in waves. Every delay from the crossing has been subtracted from what happens next. And what happens next makes everything before it look relaxed. Beaumont, Texas. Population about 115,000. oil refineries, and crawfish boils. Also, one of the most strategically important military logistics choke points on the planet. No fleet stationed here, no fighter wings, no press conferences. What Beaumont has is the 842nd Transportation Battalion and 4 strategic sea points along the western Gulf Coast: Beaumont, Port Arthur, Corpus Christi, and Gulfport, Mississippi, that quietly move more military equipment overseas than almost anywhere else in the country. In a single recent deployment, the 842nd pushed 1,500 pieces of equipment through this port. One unit, one rotation. Not glamorous, but everything the Army sends overseas funnels through places exactly like this. The vehicles are already sequenced in the same combat order that was planned back in Georgia. Last on, first off, ready to roll off the ship ramp in exactly the order the ground commander needs them. That part's done. What isn't done is the inspection. Every vehicle has to survive a second round of checks that makes the railhead look casual, because these are the last hands that touch this equipment before it crosses an ocean. Fuel loads verified, every tank drained to a specific level, enough to drive onto the ship but not enough to slosh. Hydraulic systems are drained because a leaking fluid line on a ship carrying 600 vehicles isn't a maintenance issue, it's a fire risk. Ammunition removed, batteries disconnected. Tie-down points inspected for stress fractures that 5 days of rail vibration could have caused. Inspectors crawl underneath vehicles with flashlights and mirrors, checking for cracked welds and loose fittings invisible from the outside. From the moment the first vehicle rolls off the train to the moment the last one drives onto the ship, 48 hours. Not a suggestion, a hard deadline. And the clock is already running. The Gulf Coast doesn't care about your deadline. This port operates through hurricane season, and a tropical storm in the Gulf reshuffles the entire port schedule. Military Sea Lift Command vessels share berth space with commercial traffic. A weather delay doesn't buy extra inspection time. It buys vehicles sitting on an open staging pad in salt air and rain, undoing what the inspection was designed to protect. Push past the window and you're inspecting everything twice. If a single tank fails inspection, every vehicle queue behind it in the load sequence shifts. One failed hydraulic seal on one Bradley ripples backward through the entire grid. Soldiers with clipboards sprinting between rows, recalculating positions, reassigning slots. The world's highest stakes game of Tetris, except every piece weighs between 8 and 70 tons and the board resets every time a vehicle falls out of line. In Beaumont heat, where the humidity alone should qualify as a hostile work environment with no margin for a second reset. Once these vehicles board that ship, they're inaccessible. A cracked turret ring that nobody caught here arrives cracked in Kuwait. A faulty fire suppression system stays faulty for 2 weeks on open ocean. This is the last chance to find a problem before it becomes a deployed unit's problem on the other side of the world. And the ship pulling up to the dock was built before some of the inspection crew were born. And then the ship shows up. That ramp lowering from the stern belongs to a roll-on, roll-off cargo vessel. A Watson-class or Bob Hope-class ship from the Military Sea Lift Command. 958 feet long, 3 football fields, 380,000 square feet of internal cargo deck stacked across multiple levels connected by internal ramps. One of these ships swallows 58 Abrams tanks, 48 other tracked vehicles, and over 900 wheeled vehicles. The entire combat power of an armored brigade combat team packed into one hull. Each ship costs an average of $265 million to build. The U.S. operates 14 of them. One ship, one brigade, one ramp. The people who do this for a living call it a rodeo, a play on, roll off, and the barely controlled chaos of driving thousands of vehicles into a floating warehouse in under 20 hours. Loading a ship isn't like loading a train. On a train, you can stop, back up, reposition. On a roll-on, roll-off vessel, every vehicle drives in under its own power, follows a single narrow path through the ship's internal decks, and parks in a space calculated down to the foot. No reversing, no repositioning. The vehicle goes where the load plan says it goes, and it stays there for 2 weeks. The M1 Abrams drops its Allison X1100 transmission into its lowest range, feathering 1,500 horsepower down to a walking crawl. a system designed to push this vehicle across open desert at 45 miles per hour, now threading it through a ship corridor at 2. Drivers can't see the edges. Ground guides walk ahead using hand signals because no radios work inside the steel hull. The signal bounces off bulkheads and creates nothing but static. Every turn is blind, and the internal ramps between decks are single-lane steel grades, steep enough that the driver stares at ceiling instead of floor. A stalled vehicle blocks everything behind it on the wrong deck with no way around, and recovery inside a ship is exponentially harder than on a flat car. And the vehicles keep coming. Tracked vehicles grinding up those ramps at walking speed, wheeled vehicles threading through corridors lined with vehicles already chained on both sides. The entire interior smells like diesel and hot steel, the air thick enough to taste, and the sound of treads on metal decking echoes through every compartment like rolling thunder that never stops. As each vehicle parks, the ship adjusts underneath it. Ballast tanks below the cargo decks pump seawater in and out to compensate for the shifting weight in real time. A loadmaster monitors trim from a control station, calling adjustments as each vehicle settles into position. 3 Abrams on the port side before anything loads starboard, and the ship starts listing at the dock. List too far, and the ramp angle changes enough that the next vehicle can't drive on safely. 60 tons parking above while thousands of gallons of seawater shift below. Each tank gets secured to the deck at 8 hard points. The torque specs account for 15-foot swells in the North Atlantic or the Mediterranean, depending on the route. Too loose, and a 70-ton tank becomes a wrecking ball below decks. Imagine a grand piano sliding across a gymnasium, except the piano weighs as much as a loaded 737. Too tight and the chain snaps under wave stress. A loose tank and a broken chain in the same compartment. For 16 hours straight, the vehicles roll in. Shifts rotate. Fresh drivers replace exhausted ones. The ground guides swap out every 4 hours because the concentration is brutal. One miscounted hand signal and a tracked vehicle grinds into a bulkhead. The load plan was built weeks ago, and every minute of deviation compounds. When the last vehicle rolls into the hold and that stern ramp closes, 8 football fields of cargo space sit packed with armored vehicles from deck to ceiling. The interior goes dark except for emergency lighting. The vehicles cool, their engines ticking as the metal contracts. The entire combat power of an armored brigade, sealed inside a steel box. Then the ship pulls away from Beaumont, and the pipeline hands its biggest dependency to the last people anyone would expect. No warship escort, no military crew. The people steering this ship are civilian merchant mariners, contractors, not sailors, working for military seal of command under a logistics command most Americans don't know exists. During Desert Storm, Sealift moved 94% of all cargo to the theater. Not airlift, not C5s, ships. That hasn't changed. What has changed is the fleet carrying it. The Bob Hope-class vehicles entered service in the late 1990s. The Watson-class ships followed shortly after. Both classes are older today than the BC-25A that flies the president, and the replacement program is behind schedule. For 2 weeks, the reinforcements that a deployed brigade is counting on sit chained in the dark belly of a cargo vessel streaming through open ocean. The merchant mariners sleep in shifts. Vehicles sit cold and silent, rocking with the swells. 2 weeks later, that ship approaches a port in the Middle East. The ramp drops. But before a single vehicle moves, advanced teams board the ship and work through the cargo decks, bringing each one back to life. Reconnecting batteries, refilling hydraulic systems, topping off fuel, recharging fire suppression, syncing radios to theater frequencies. The exact reverse of the Beaumont shutdown sequence, executed in the dark on a ship still rocking from 2 weeks of open ocean. The first M1 Abrams rolls off in exactly the order it was loaded. Combat ready, in combat sequence, every system refilled, reconnected, and operational. The turbine engine spools up on the cargo deck, and 70 tons of American armor drives down a steel ramp into desert heat that hits the crew like opening an oven door. Behind it came the Bradleys, then the fuel trucks, the recovery platforms, the command posts on wheels. The entire brigade rolling off in combat order, ready to fight. And if you want to see other ways the U.S. military transports equipment, you should watch this video. Bye for now.